My name is Thomas Meyer, and also a very warm welcome from my side. I'm responsible for sales, product, content marketing, and in this global role, I'm the one that supports Ellen today in her role as the host, and I also will take care for the Q&A session afterwards. So as mentioned by Ellen, please don't hesitate to type in your questions right during the presentations to refer to them afterwards in the Q&A session. Said that, it's time to hand over to our main speakers, to our subject matter experts, Claudio Foti and Daniele Duc. And I'd like to ask you to introduce yourself very quickly. Thank you.
So thank you, Thomas. Hello, everybody. My name is Claudio Foti, and so I work in Sealing Solutions since 1997 as a product development and a product industrial manager, especially for industrial bearing seals. And I am located in Villanova d'Asti. Daniele.
Thank you, Claudio. My name is Daniele Duc, working in SKF Group since 2006. I made two different experiences, first in the sealing system and secondly for about 10 years in the applications, in particular for the car units. Now, since 1 year and a half, I'm taking over the responsibility for truck and car wheel end products.
Okay, thank you, Daniele. So we can start to show just a small presentation where the intention is to show where we are in terms of solution and of course technology. Just starting, so why we would like to have this, let me say, short presentation and to have the possibility to explore better the application and the sealing function. As you can see from the picture, so if you have a good sealing, so there is not any issue on the bearing, but if you have some problem or some issue on the seal, you could have also big issue on the completely units. So the importance of the seal that somebody think that is a commodity is not so this. So it's very important to have the right choose in terms of design and also in terms of material, to be able not only to, as we can see from this picture, just to be able that to have the main function of the seal, as you can see from the picture. So we have seals integrated to the bearing, able to keep inside grease or oil and keep outside the contamination. So we have, of course, the same function for bearing seal or seal alone assembled in outside to the bearing. What is very important is that, of course, the seal cannot fail, because if we have grease leakage, of course, we can have a certain limitation on the life of the bearing. But the same, if we have the contamination ingress, we can have more or less the same failure on the bearing. So again, what is very important is to have the right choosing for the application, for the right geometry, but also for the right material. One typical case where it is possible to have a big contribution and to offer a very good solution, to have a very robust tools, is to have a different configuration. So this is just an example where it is possible to have bearing seals and to have a protection of the bearing and to keep a certain grease inside to the bearing, to have a second barrier able to keep inside again grease or oil or separate to media, and to have again another extra sealing that is machined in this case, where it is possible to have an extra protection from the environment. So just to have a good protection of the complete system and to avoid any issue during the application. Just some typical example of a wider range of application, of course. So we are speaking about all bearing family, from the small DGBB to the bigger one that is for the large seal or SRB. So where it is possible to assemble and to have a component integrated to the bearing, or it is possible also to have an extra component outside to the bearing. Here there are some typical examples where it is possible, where it was possible to have this kind of job and to have a very good solution to offer for the market. In this particular case, so the spherical roller bearing, this is a typical, as you can see from the picture, is a typical work of the bearing where there is oscillation. And there was a different solution in the market, and so we standardized using just one common solution, and to fix some problem in production, just to have the possibility to improve the logistic part from the factory. And using this kind of geometry we was able to standardize not only the bearing but also the seal, and offering a very good solution, able to reach more or less 50% of friction reduction. That is a very important point because, of course, it needs to have also less energy consumption. And to improve the grease life means that we can increase the interval of maintenance of this or lubricate the part, and also the possibility to have higher speed. In the reality, in the final application, of course, so we have a good advantage because, again, so there is the possibility to reduce the friction, to increase the speed, and of course to reduce the complete unit, changing the system. Of course, we need to have a different solution and to assure that the grease inside to the bearing remain for long time, for I don't want to say life, but more or less, yes. Other typical example where it is possible to customize and to offer a very good solution in terms of sealability, and of course to fulfill the complete requirement from the application, is always a spherical bearing, but in this case is not for the elevator market, but is for industrial, in general industrial. Also in this case, so the solution was developing according to the different requirement. And in this particular case, again, so we fixed the parameter based on the current solution, and now we are able to reach more or less the double time in terms of life. The sealing function is much better, and of course, so we can assure us a different performance on the seal, on the bearing, complete bearing. This is a typical example where this part is allocated. Of course, this picture cannot show the completely, let me say, leakage of the unit, but is how we can, or the customer can, grease the part just to avoid to have a different interval of greasing. Of course, we have a huge of grease that come out from the bearing, and so this is a point that we would like to avoid, not only for the bearing point of view, but also from environment impact and what else. Using this kind of solution, of course, we are able to keep better the grease inside, and also to offer the possibility to grease the part without any other issue. So when the grease comes into the bearing, of course, the lip will open, and so when you have just some small grease, so we know that the bearing is completely full. Same application, but different bearing is used for this kind of solution. In this case, so we are speaking about, again, more or less similar application and similar final industries, but the bearing is not a spherical roller bearing, but a taper bearing. In this case, of course, so we have a different condition in the application. Was possible also to allocate a different solution, not only three different lip or two different lip, but in this particular case we had also the possibility to assemble the cassette seal, also because the environment in this case is different and quite, let me say, severe. Other big family is the plain bearing, where the importance of this application is to have a very clean surface where the seal has to work. Otherwise, so considering that this kind of bearing there is not grease, if we have a part that is not able to have a good solution, a good seal system, we can fail in a very short time. This is a typical bearing that is used in many industries, not only for the industrial application, but also for automotive, trucks, agriculture, and so it's very important to have a very good solution to able to avoid any problem on the bearing. And the typical solution are like the three different solutions that we can see here, where we have the, let me say, solution that is able to be anchored on the groove of the bearing, but we have put more attention to have not the possibility to, when there is the rotation of the bearing, to avoid any problem in this area, where when we have the rotation, so the possibility that we can have a flip, the lip reverse of the lip, it's quite common. We have not to create a lot of friction, because otherwise we can damage when there is this, let me say, movement, oscillation of the bearing. And of course, so we have to offer a solution that is very robust in terms of sealability, able to avoid any water or contamination ingress into the bearing, and able to keep very clean the surface of the bearing and avoid any friction or any other problem. The industrial application where this kind of bearing is, of course, used, as you can see, is used for many industries, and it's very important. So, for example, in this particular case, we have a concast is used for metallic part to create the metal, and so the temperature range is very high, and of course, so we have to put attention to the material instead to the, let me say, the geometry. While, for example, it's very exposed like the agriculture. In this particular case, the issue is not linked to the temperature, but is the environment and the contamination. Make a difference means to have, of course, a very good solution. We know that, of course, to work and to substitute or to maintenance the part in this such machine, so it's a very huge job, and so it's spending a lot of money to have a very good solution. So means to have a good solution means to avoid any problem and to have not problem and the issue in the real application, but of course to avoid any other extra cost due to the maintenance on the repair, or to, let me say, have interval of the relubrication. So the intention is to have a very robust design that can give the best performance and the best give the best value added possible to the final customer. One other area where we are focusing our attention is the food and beverage. Apart the different geometry that is used, so as you can see, there are seal alone mounted in the complete unit outside to the bearing, or there is a different labyrinth seals used integrated to the bearing. The important things is that we have the material compatible with this food and with this market. Not only the rubber material, but also other elements or plastic material that is used for other applications. Other area where we are present, and so we are investing in a lot of time and money, it's the agricultural application, where there are different solutions for the different segment of this area. So, for example, where there is a tractor and the axle on the tractor, we have a pinion seal, and so also will seal. The typical example is the MAD 11 that we have, that is a very robust design the concept was developed in order to keep contamination outside. You can see that it's a very robust, and so there are a lot of lips that able to keep outside the contamination, water, mud, and what else. And so in this particular case, so we have the wheel with oil, and there is a seal able to keep inside the oil. So there are many other applications where we have more or less the same extra lip for the contamination, but instead to have spring and lip dedicated to the oil, there is grease application, and so we have a different concept. But at the end, the concept is to have a very robust design, a concept like a cassette solution, just to improve and to avoid any water ingress or contamination ingress. Of course, there are many other applications. There are some typical examples where we have a tillage application, seeding application, and moving application, where of course the exposition of the contamination is completely different, and of course we can have very duty application, light application, and so on. So what is very important is that so we are able to customize the application in according to the solution in according to our application, and so we can adjust and customize the geometry, but also the material that we can use. Now I can give the role of presenter to Daniele, that can show some other typical product and the tool that we use to develop the solution. Thank you.
Okay, hope you can hear me.
We can, but you need to share the presentation.
Yes. Okay.
Please go ahead.
Okay. Now we move to other kind of products that we are going to see are the HBU hub bearing unit used for car applications, and the THU, that is track hub unit, of course used for the truck market. Here an example just to give you an overview of what does it mean kind of bearing for a car. This is in particular a third generations bearing, then we will see later what the generations, and I would like to show you all the parts of the bearing to have a better understanding. First of all, on the left side you can see this is the wheel side. To identify the bearing in outboard side, inboard. We have usually a rotating ring, that is the internal one. This one in particular for this thing is called FIR, flanged inner ring. We have a flanged outer ring, that is a static ring in this part. We have the seal, inboard seal and outboard seal. It's important to call them in this way because, for instance, for the HBU3, outboard and inboard seal cannot be always the same seal because due to the fact that during the assembly we have to take care of some operations. And then we need to avoid any kind of issues due to, for example, lip reversals during the assembly. And we have on the outboard side a flinger in this specific case. That means it's just a metal part that is used, this one. It's a metal part that is used for the lip counterface. We have encoder, that is magnetic rings used for ABS system. One is for the about the car application is 99% on the inside. Flinger and encoder are providing the seal lips counterface. Provide a seal with the counterface. That means, for instance, in this specific case, the complete system, and we call it cassette seal. That means seal plus recorder. HBU third generation, that is the picture that you have in front of you. Seal because we supply separately the seal and the finger due to assembly operation. Really important to know in order to design the right seal for the right application where the contaminant is coming from. And let's say it's important to know it because from the geometry of the bearing and from the corner layout, we can know which is the flow of the flow of the contaminant, and we can design seal for the specific application. Important to know that for car in particular, but also for truck, we are going to provide customized solutions and not standard solutions for all the product. This is due to the fact that we have changing in dimensions, changing in performances due to customer specifications. Same things we can see for the truck application, and this is layout we have, for instance, for a bearing that in this case is a TH1 used for this overview. One of the main differences is that for the truck we have often, more or less always, the rotating ring that is the outer ring. The inner rings in this case are the static rings. Then we have for truck we have two different kind of seals used for inboard side and outboard side. This is the wheel side, and it's an outboard seal, and for a driven unit, as the one shown in this picture, on the outboard side, we have an oil seal. Oil is coming from the axle, and then we have bearing is more or less always lubricated. Have this mix. We don't have to have the side contaminant is, let's say, external environment. Then kind of seal that we are using in the external side is like the one. Really important to know about the seal life and is close to the end, let's say, then it means that we are starting to have some leakage inside. It means that also the bearing life is going to be at the end. Now I wish to show you the background about hub bearing unit and track hub unit. Starting from the hub bearing unit for car, we can see that we can have different kind of product. This one is the HBU1. HBU2, now I will explain you which is the main difference. And the main difference in between those two generations of bearing is that for the HBU1, we have the inner rings. While for the HBU2 standard one, we have the outer ring that is flanged. And for this specific HBU2 generations, we have also the ones that is called reversed. That means that we still have the in this specific case, we have the internal ring rotating. We have cases where we applied the HBU2 standard one with the outer ring rotating. Then moving to the third generation, that is the one I showed you before, we have external ring and internal ring with flanged. We call it flanged internal ring rotating. For this specific case, we have also tapered roller versions. Going through the applications for the tracks, we have also kind of bearing that we call the track matched unit. We can have assembled units and track matched units itself. specific product, the seals are assembled by the customer itself. Then we can move on the other generations. That is first generations is very similar to the car applications, and then it means that we have inner ring.
Daniele, sorry for interrupting. There are some interruptions in the audio. Could you please move your microphone a little bit closer to the mouth? Otherwise, we have some interruptions.
Yeah,
I guess that's
better like this.
Yeah, hopefully.
Okay, thank you. Then here we have the first generations of track hub unit. We have no flanged on both inner rings and outer rings. And we have here the generation 2 that is with the external ring with the flange. Those are kind of bearings that we are supplying to our customer, and you have to consider that when we give these products to the final customer, the sealing system that is provided directly by us is equipping already the SKF bearing units, both car and both truck units. Then I would like to show you a way of working of SKF. Then first of all, what we take a look of final applications, that's clear because we need to know where the seal is applied on the bearing, but not only bearing, but we need to know where the bearing is applied, and it means that we need to understand about the corner layout. We need to know really well the customer specifications. We go through the specifications of our customer in order to understand where is possible to use a certain kind of family of product or other ones, or maybe also to identify that we need to generate a new customized seal for these specific applications. Then validation tests, really important, because those are the tests that can allow us to say that seals can work into the market, because validation tests are in part coming from specifications, that means from final customer that knows very well which is the level of performance that our seals and our complete unit has to reach during the test. And then it's important to know which kind of method we have to use for testing. Then we go through all those voices. That means mud and slurry test, friction test, etc. These kind of requests are really important to be evaluated at the beginning of the project, because as you can understand, performances in sealability and performances in frictions are really important today, because friction is one of the most demanding things coming from the final customer. But at the same time, you can understand that keeping the same level of performances by having less frictions in our system is a good challenge. Then we got to evaluate the bearing loads. That means that we got to see which is the relative movements in the parts and see in which way we can keep always the followability of our lips with the counterface, durations of the test, mud flow rate that we have to have during the test, nozzle positions, that means where the contaminant is coming through, nozzle size that is also evaluating not only the flow rate, but the pressures of mud that is going against the bearing during the validation test, and of course the criteria of acceptance. All those tests has to be evaluated at the bearing level and component level, because we have something done directly on the seal itself, while we have several tests done at bearing level. That means complete units. All those points can allow us to identify or create a completely new seal concept. In addition to that, we got to add also some other study. We do these activities, of course, when we receive new requests, for instance, regarding low frictions, by having also the possibility to include new labyrinths. That means that we need to have the space to create this labyrinth, of course.
not mainly on the seal only, but we can also consider a labyrinth made in between seal and bearing. And if we have the possibility to work with the final customer, maybe we can also to study something together with him, including the knuckle and the corner layout. In this way, we can reduce the frictions in a sensitive way by keeping the right performances. Then we have the possibility to make simulations of dynamic simulations for seal. This is really important for us because it can lead us to have a virtual design. Then let's say in the next future, what we would like to have is a virtual design that can allow us to understand in which way the simulated seal can be very close to the real situation. Then simulations versus experimental results. It's of course this is a key point because we do simulations in terms of magnetic performance and in sealing performance, and we can check all those results after making validation tests. This work can be done only if there is a big synergy in between departments. In this specific case, we are going to consider global research and innovations that is inside SKF and product technology development that we have in SKF Seals. Now I'm going to show you which is the market requirements and trends that we have for the friction, let's say. Then starting from the very beginning, this is kind of old seals that we were using in the past. And this is a kind of seal that is still on use today, but is, let's say, is something that is going to be changing due to the customer request. We have some other product, as you can see in the outboard side, we have in the blue picture above, we have a seal that is sliding against the bearing itself, while in the bottom side, we have already a cassette seal also on the outboard side. This is due to the fact that customer is asking for having also stainless steel counterface for our lip. Then in between today and tomorrow, because we already have some solutions in terms of labyrinths, of course, considering that frictions is really demanding, we need to move with the new generation seals. Then when we see labyrinths, we intend all the parts that is in front of the main lip. Main lip is the one touching the counterface. Then everything is done usually with a not contacting lip, and it is designed in order to keep contaminant outside and to allow as a minimum quantity of contaminant to reach the main lips. Of course, we are also working on new solutions. They are under development, and we already tested some interesting solutions, and we will be happy to have the possibility to show you in the future. And if we fix the axis of time in years and frictions in Newton meter, we could see that that trends coming from customer requirement is in these directions. And let's say it means that from old yesterday seals, let's say, till tomorrow seals, we can see that this trend is asking for having a frictions reductions. Of course, this frictions reduction is not only required to seals, but it's required to complete units. Then we think that the key is to have seal plus bearing plus knuckle to be studied all together. Then let's say we already provided some solutions working on the seal and the bearings, and we had also the possibility to design some solutions with the final customer by giving also suggestions on the knuckle geometry, and it was and we were able to reach very good results. I'd like to show you also what does it mean the trends in terms of magnetic requirement. First of all, I would like to identify what we mean for air gap, because we work, let's say, mainly with crystal air gap. And the crystal air gap is the one that can allow us to understand if our encoder is performing as per customer requirement. We have driven units where the air gap is, let's say, the general distance of the sensor from the encoder surface is in between 1 millimeter and 2.2. And we have also not driven units where the crystal air gap is much higher. Then it means that it's more critical to be able to read the signal and to supply this kind of solutions to final customers, just because the sensorizations in the final application are changing, and then it means that we also need to move with these new sensorizations also in-house in order to be able to follow our customer. And this is something that we are already doing, of course. Of course, this change in the bearing by using a metallic cap in between the encoder and the sensor itself is also due to the fact that by fixing a cap, it's possible to avoid to have seals inside the bearing. Then no seals means no frictions in this area. And this is one of the points that is used in order to reduce a lot the frictions of the bearing for the not driven bearing. Then, considering the corner layout and sensorizations and magnetic field, until yesterday, let me say, 2 years ago, we were focalized on one directions of the magnetic field that we called Z directions, that is the one perpendicular to the encoder surface. Now our customers are demanding magnetic field in the 3 directions, and the reason is because also sensorization is going to change, and they are going to use sensors able to read signals in different directions. Also, in this case, if we put the 2 axes in time and years, we have seen the trend is to increase the air gap. And maybe the reason is due to the fact that those new sensors are more sensitive respect the previous ones. And at the same time, the way of reading signal is changing. Also, they are using different kind of technology, and then they are able to get the right value they need for the electronic systems of the car, also by keeping higher air gap. The key for us is to be able to measure and to simulate this signal in the 3D directions. We are already equipped with this specific equipment, and we already can do these measurements in some locations. Then we need to enlarge our capability in that directions. Then let's say advanced sealing solutions for automotive and industrial means for us sealing systems as differentiating factor, and it can be possible for us because we can work together with our colleagues in the bearing area. Then we can fix everything together. Then we have the possibility to have frictions reductions, sealing ability, and increase maintenance intervals. And it can be done also working with this synergy in between the 2 areas. Design to cost from idea to manufacturing. We already started also in this phase. In fact, we have also our business development going to speak with manufacturing costs and so on at the beginning of the project in a way to identify in which way we can design the bearing, in which way we can design the seals, and in which way we can optimize the complete system. Then testing and material development, this is something that we do continuously. We are going to be better day by day in terms of testing in order to have much more reliable results coming out from testing area. And also material development is really key for our product, in particular for the sealing system, because rubbers needs to be competitive in front of environment, chemical agents, and then it has to be compatible with all the environments that we need to face for the product. Then reduced energy consumptions, and we can do it also by reducing frictions on the unit itself, increase efficiency and increase reliability in terms of course, performances. New way of working we have that is already implemented and we are using since, let's say, more or less 2 years. We have the two parts. We have SKF bearings, we have SKF seals. We are recirculating information. We are sharing knowledge between us in order to understand which is the best solutions. We do it with the product engineer, plus product development and product design, with testing laboratory, GBI, that is global bearing investigation, that is really important, is located in the bearing area. We have a material and testing lab here in SKF Seals, and together with this, we are working with Global Research and Innovations that is located in Netherlands in order to have material modeling, advanced simulations, advanced testing. And in this way, we can have on board the expertise, competencies from both sides, bearing and seals, in addition to our specialists in simulations. Doing work in these directions, we are convinced that we can give and deliver to our customer a most robust, customized and innovative solution. Here, just an example regarding fluid dynamic simulations that we have done on a specific project. And here on the top right, highlighted by the red arrow, you can see where the simulation is saying where the mud can arrive at the end of the validation test. And this is a pictures of the validation test that we have done. And on the bottom right, you can see where the contaminant was able to arrive. Of course, this match can be done only by fixing together expertise from simulation side, calculations, and expertise from experimental. Then we need to give the right inputs to our colleagues in global research and innovations in order to perform the right calculation. Here, a brief example regarding a real case that we had for a low temperature applications. And then what we have done was a performance comparison with a project that we were doing in order to better understand the performance of the seal for low temperature. We have done mud and slurry test and low temperature test, and in order to arrive to an SKF seals proposal. In the first part of the project, we were considering a dynamic simulations approach on a seal that failed in the past this test. And at the same time, we were putting on the table also another test that we did in order to understand what the meaning of passing the mud and slurry and the possibility to pass also the low temperature test. Mixing and combining those informations, we went to study all the customer specifications and being able to make the right simulations. And with the help of the specialists in simulations, we were able to find the right solution. Let's say the step one on the left side is providing the scenario that we used for starting, and on the right side, the step two is what we were able to deliver. Then doing on the step one, as you can see, we have, let's say that's a simulations that is keeping in considerations all the boundary condition, all the constraints that we have also on the bearing, deflections, bearing load, temperature, and so on. This is done at very low temperature, let's say more or less minus 20 degrees. On the upper graph, you can see forces. That means that we have some area during the 360 degrees of rotations where we are going to lose forces. That means no sealability. In the new design, as you can see, the scenario is completely different because we were able to keep good followability, let's say full followability, and forces necessary to ensure a performance. Of course, we were playing on design, we were playing on material, we were considering the speeds, we were considering the temperature and many other factors due to the rubber itself. Advanced software tools has been also used in order to simulate the friction. Here you can see the effect of the temperature during the test. We have done this test at one speed only in this specific case, and we were combining the effect of the leaps in order to have the combined effect that is the total friction torque of the part. Here, quick example of virtual productions with compression set. Left and right side are presenting you the seal into the mold into different positions that we go to evaluate when we think is necessary to do it. Otherwise, for some product, for many products, let's say not for some, we are able to understand which is the best positions, the best way to produce it with process we have. We have also the possibility to make parts by injection process. In addition to that, we have to remember that in our global research and innovations, we are not only doing simulations, but we are also doing experimental tests, because we need to link the two parts. Then let's say when we move with a new challenge, new scenario, we are going to evaluate which is the best way in order to make these simulations, but at the same time, we are going to study with the help of GR and I, Global Research and Innovations, which is the best way to test the seal in that particular conditions. Here, I can say we are convinced that the right seal can make all the difference in ensuring reliability and performance in an entire machinery system. We have the possibility to do it because we are working with our colleagues in the bearing side, and then we have the possibility to put together all our knowledge in order to arrive with one solutions and one integrated solutions for our customers. And here, main contact for the product that we presented today, and that's it from my side.